first I will talk about my understanding of trustworthy data science and why we need to do it. And then I will talk about a few studies that we have done in the space of transparency for transparent data science, explaining models and predictions, and also the fair and debiasing in the process of doing particularly social media opinion summarization. And then I will talk about responsible information recommendation, and I will then do a final discussion and conclusion. This framework here actually is from the European Commission, the Data Science and AI Alliance. They're talking about the 7 principles to achieve trustworthy AI and data science. Okay, I especially want to highlight here. So like this one is saying humans and users are very important, and AI should be reliable, irrespective of the possible adversarial attacks, and also data privacy and governance is very important, as I think both Rocky and Shazia mentioned just now in the information resilience space. Of course, transparency is about explaining the AI system, and also not only explain the prediction, but also tell people the capability and limitation actually. And of course, for fairness, because the users are coming from different groups, and diverse and inclusiveness in the prediction, and the values of the AI system should be aligned with our society. And of course, accountability if there's something goes wrong with the system. So you can see here, based on the principle, when we apply it to data science, trustworthy data science, and actually in reality, we face many different challenges. So that's why these challenges become the focus of my research with my students. And we have lots of data, unlimited data, the so-called big data, okay? And the data actually comes from very different sources, and importantly, unfiltered. And because of that, the data actually has bias. And this picture shows a site. It's a very commonly used website. It's a media check and fact-checking website. In this database, there are 7,000 information sources from different medias and journalists. And it says every information source has its own bias. Some, in the political space, some are left-leaning, some are right-leaning. They have their own viewpoints. So the data they have generated has their own bias in the data. And this picture here shows, even if that we have data that are, collected from the social media, and we have been careful in the collection process, we may have accidentally introduced data into the data process. Shazia mentioned data curation and data gatekeeper. So social media data actually has been used even for disaster management. And this picture shows there are over 20 million tweets that are collected from Twitter and used for the disaster of Hurricane Sandy. Great, big data, right? But later research, deeper investigation into data found that actually these 20 million tweets are all from Manhattan, and people may think Manhattan is the most infected area, is the most where the disaster center is, but it is not. The bias is the data is biased because Manhattan has the highest mobile coverage and the highest Twitter users. So you can see that when we analyze this data, put it into action for disaster management, the bias that can be in the data embedded, not consciously, but accidentally. So these two pictures are actually highlighting, because of the bias in the data, and statistical models and machine learning models can carry on this data and propagate into the system and for later prediction results. And so that's the reason. So I've covered this, unlimited data and the biased data. And what's more serious about the data is not all information in the data that we are analyzing are true information. So there is misinformation, and lots of them in the data we are using and analyzing. So this picture, actually, it is showing the New York City police department is underwater. And actually, this picture is a fake picture. Okay, it's a made-up picture. And this very, terrible picture is a hoax about a Momo challenge, and has been widely spread across the world on social media in 2018 and scared many parents and many children. Okay, and of course, Donald Trump was the king of, misinformation spreading. And during the COVID-19 in 2020, actually, the World Health Organization say it's not only a pandemic, it is actually an infodemic. That is, there's all sorts of misinformation spread about COVID-19, about the vaccine, about everything. And actually, this is an example talking about, the whole COVID is because this is from a conspiracy theory that is saying it's all Bill Gates who is playing and doing the bad things. Okay, all these misinformation on social media are in the data. And when we use the data for analysis, we really need to take this into consideration. These are the challenges. But I talked about just now that user is very important. Now, what about users in this information space? Now here, this Pinocchio nose shows that according to psychology, we human beings are actually gullible species, and you can test your gullibility. And we tend to, the whole society and development of our civilization depends on trust others and to get information. All right. So, but this becomes a problem because with the credulous users easily believe information that is presented in this age of the internet, and there are all sorts of unfiltered information everywhere. Then you really have to make a judgment, what to trust, what to suspect, and what information should you take in or should you reject. All right. So we actually did some research in this area, and this is a paper that we have published, and we studied people's behavior about trusting information and the credibility of the information. And what we found is that people are really trusting the information based on the service value, whatever is presented, and even more so than machines. And this science paper actually told us the spread of misinformation actually is not because of machines, it's because of human spread misinformation, not on purpose, but may accidentally, okay? Because there's novel information, some information that we're not familiar with, and we just spread it, all right? So because of this, and we are working on, trustworthy data science, and especially, I think, these areas we are working on. So we want to, for transparent data science, we want to explain the machine learning models for our predictions, and we want a system that is fair, and we can specifically de-bias or try to reduce bias in our system. And also, we want to do something that is responsible, as aligned with our social values. Okay, so with that, I want to discuss a few pieces of research that my group, that I have done with my students and collaborators. So the first topic is on combating misinformation with explanation. So we have, what I'm going to talk about next is based on several papers that we have published in the past several years. And specifically, what type of misinformation we focus on? Actually, we're talking about rumors. Roughly speaking, what are rumors? Rumors are unverified story that are wildly spreaded. And I'm talking about in the context of social media. Okay? And social media actually become the super spreader of rumors. Whenever there's a news story and all sorts of information about the news spread on social media. It can be true, can be false, can be unverified rumors. We don't know what they are. Okay, And especially this is saying, as what I mentioned just now, during the COVID-19 infodemic, all sorts of rumors about all the different topics about masks, about, the government policies and the measures and home therapies, all sorts of rumors and on the social media. So we to achieve detection or try to help people to only see true information on the social media, and detection is very important. And there are fact-checking organizations, journalists, they work on it. However, to push the rumor detection to scale, we do need machine learning algorithms, we need AI. So to do the rumor detection to scale. And to achieve that, we use machine learning models. But one important issue with the machine learning model is it's, neural models, artificial neural networks. It's like here, and we put the data, the tweets, the social media tweets into the social media, into the model, and we see an output. And the social network is layers of neurons interconnected like this. And it's just like a black box. We throw something into the system and something spit out tell us, oh, this is rumor, this is not rumor, this is a true piece of information, that's a false information. How can we explain it? Okay, so to make people to trust it, we must explain it. So that's something we want to focus on. So what we have done is we have proposed this system, of course, relying on different information sources for rumor detection. So this is a paper that was published in NACL, an ACL, a Natural Language Processing Conference. So you can see here, what we use as input are actually the conversations about, social media conversations. So like, say this is a source Twitter post, and then these are the responses from people adding comments, and there are further responses or retweets, and then the information propagated. So we model from the social media conversations, we extract the user propagation network, which is the user tree, the users that involved for retweeting the information, and also we look into the content and we model it, connect all the tweets and the comments, look at the textual content of the tweets, and also, we look at the conversational structure. And from here, all these, so this is a graph attention network, and this is a transformer network, and this is combining BERT, which is a transformer architecture for modeling the sequence of tokens together with a graph attention network. Put all these neural networks together, concatenate the representations we have learned, put it into a fully connected layer, and then finally we have a soft mass for prediction, whether it is true rumor or false rumor, is it unverified or it is false. And then we get good results, okay? So you can we compared with the baselines, we see good results, and then you have to believe me, I have achieved good results because these numbers show that we have better results. Now, and all these three data sets are very credible data sets. They are public domain data sets. This is Twitter 1516, on various rumorous topics, and COVID is a COVID data set on various topics about the COVID rumors, and also the very last one is Chinese Weibo, talks about, there are rumor annotations by the users, and we have verified, we have good results. There are numbers that shows us. But, you just have to trust me. And would you use our system? And how can I convince you to explain the system? So that's what we're trying to do as well. So this, what we have done is, in addition to the results, we also analyze and try to explain how the system reached such conclusion. So what we have done is we apply causal mediation analysis. I'm not sure whether any of you is from the medicine domain, but in the medical domain, causal mediation analysis is widely used to try to figure out the effect of any drugs or interventions for medical purpose. So X is the treatment and Y is the real effect, but they also, Z is the mediator. So to try to find any confounding factors. So there is direct effect and indirect effect. So what we have done here is we apply this causal CMA, causal mediation analysis, to the domain of a rumor detection, apply it onto our neural networks. So this is our mysterious network. This is the black box of duck. And what we are trying to do is we do two types of CMA analysis, trying to open the black box. So the first is to analyze the total effect. That is, when we mask any of the tokens or when we mask any of the tweets, what effect would it make to the final prediction of the rumor, of the rumor category? Okay, so we measure the total effect. And also, we apply the intermediate Z. We try to find the confounding factors and Z in applying it to here, to the neurons and the different layers of the neural network, try to explain how we get the prediction, whether it will make any difference, what's the effect. All right. So with this, we are able to review some of the internal workings of the system. So here, this figure on the left, it is measuring the total effect from manipulating or masking the tokens and tweets. What effect do we get? And actually, we verified with the human journalist annotations. So this tweet actually, it is called a turnaround tweet. It's actually annotated by a journalist telling us, by reading this, I can tell the turnaround, I can decide this is a false rumor. All right? And we measure how our analysis match the human judgment. And this figure on the right explains the indirect effect when we mask any neurons or some of the neurons, what effect and it has. And you can see the earlier layers of the neurons have wider effect and a higher effect. That's not surprising because it has, connections to many neurons to higher layers of the neural network. Okay, so a quick summary of research in this space towards, our first topic. That is, we use neural networks for rumor detection, for misinformation detection, but we also really need to try to unpack the black box to explain our prediction. Okay, so that's the first topic. And the next topic that I want to talk about quickly is about the bias management in opinion summarization. So, so these are some ongoing work that we are working on within our group. So what do I mean by opinion summarization? Public opinion about public attitudes, right? And traditionally, we rely on surveys, we rely on polls to get what people think, what are people's attitudes and opinions. But research has shown that actually social media, especially during the 2016 US presidential election, it has shown that actually social media has the power to manipulate and really change people's opinion. And after reading 10 tweets, actually people can form an opinion about something. So that's really scary, all right? So what we are trying to do is to summarize the opinion using machine learning so that we can understand what people are thinking. And reviews are another a rich source of public opinion. So if we want to summarize the opinion from reviews, actually that's has importance for the consumers. Well, Shazia mentioned about information consumers. So because the summarization process, the summary that are generated has big influence on users when they decide for e-commerce applications. Actually, on the other hand, it also has big influence for the business reputation because, the reputation of the business is affected by these opinions. And so they pay, the businesses are very much interested in opinion summarization. So because of this high-stake application of opinions, we want to make sure our opinion summarization to be bias-free as much as possible. So that's the purpose. But we face challenges. The challenges are, first of all, the data is biased. not, the data itself, the information sources are biased, but also when we do the sampling, it is from the whole population we take this part. So we have biased data. And also, as what I mentioned just now, machine learning itself, the model itself has bias. Like the machine learning model has its own viewpoints about things. And recently, actually, with the development of generative AI, I saw the very interesting topic in the program that you're going to use ChatGPT for research, which is a good thing, right? That's the positive side of these AI tools. But the negative side of these AI tools is people can use these AI tools to generate contents, lots of them, very easily. And they can use this to, to defame others, generate fake information, and it has its own bias. And Rocky mentioned just now the large language models, when Google does the translation, it biases doctors for he rather than she. There are inherent bias of these large language models and generative AI. And when we apply it to a task like opinion summarization, how will the bias flow into the downstream tasks? So how do we avoid that? So that's what we are trying to do here. Okay. And so as I said just now, our goal is for, control the bias in opinion summarization for social media, data, for reviews. And these are the two. I'm going to talk about two pieces of work we are working on now. The first is how do we measure the bias in social media summarization, particularly Twitter. We use Twitter and using large language models. All right. So this is the process from the tweets, which are the source input. And this summarization model here actually is based on large language models and actually by what we call fine-tuning the large language models for summarization. And then we have the summary. And then we develop a system identifying the bias in the summary, at each sentence, and so that we can measure it in whole. And on the other side, we also measure the bias or the political stance, like in the source tweets. And then we're going to put them together and compare and measure. So try to measure on the scale whether, the summary is left-leaning, right-leaning, or it is more very much neutral and neutral, not too much left or not too much right. All right. So here is our two preliminary results I want to present to you. So this table is actually based on the results that we experimented on a Twitter data set about COVID, about political topics. So what we have in the input, we have about 1,000 clusters of tweets, and each cluster have a collection of tweets, and we summarize on different political topics. And the models we have used, all these, they are actually large language models, and BART, an early language model, and GPT-2 is the predecessor of GPT 3.5, which powers ChatGPT, and then T5 is another. We have all these different large language models. As I noted just now, these language models has their own inference bias, and what we are doing here is in a zero-shot setting, apply this for summarization, and we want to measure what's the bias, the political stance in the summary result. And here's what I show. Negative means left-leaning, okay? And positive means right-leaning. And closer to zero means more balanced, okay? There is not the neutral. And you can see that, obviously, there is bias in the zero-shot application. Zero-shot application means we don't do try to control the large language model, just apply it directly for summarization. And this table here on the right shows, what about if we try to control the language model, try to fine-tune it using different strategies? So these are the different strategies we call adaptation. So how can we adapt it for better summarization results, for better performance? So these are Rouge scores. Rouge scores measures how well the summary, the machine generated, compared with the ground truth summary. Okay, and these measures again the shift in bias, left leaning and right leaning. And you can see what we have found roughly. I won't go into the details of every number. So these highlighted numbers, many of them appears in the last line of the different adaptation adaptation methods. Actually, it says the less we manipulate and try to fine tune it, the less bias we try to deviate it from the original bias in the language model. All right. Of course, the less fine tuned, the performance may not be that good. So there's this dilemma that we need to pay attention to. So this is a preliminary result we have got on analyzing the bias in opinion summarization. So on the next topic of review summarization, reviews has lots of opinions. So classically, if you summarize the reviews and using some tool, it will generate a review like this. What we have found is for diverse opinions, both positive and negative, and on different aspects, it can be inconsistent. And it is not good at handling the diverse opinions and the positive and negative about different aspects about the products and services that we talk about. If you look here is talking about food was good, and then they talk about food was mediocre at best. So all these contradictory opinions in one summary, which is very confusing for the end users, for the consumers. So our aim, our goal is, what about, we want to, for opinion summarization, summarize the key points, distinct key points, diverse key points, but both positive and negative opinions, all right, rather than one-sided. So this is some work that we have done. And you can see that from the original input of the reviews, and we summarize the key points and into positive and negative key points so that they are distinct, talking about food and service and stuff, both the positive and the negative. And more importantly, we also include not only the majority opinions, but also the minority opinions. That is, we quantified with the salience scores. That is, how many, how much support is there in the original reviews. So with this, we aim to have a fair summarization of the diverse key points that are covered, both positive and negative, about certain services and for e-commerce applications. So here is the framework of our system. We have done, an aspect-based sentiment analysis from the reviews, and from there, then we extract the automatic matching of the positive and negative key points, and then we try to do contrastive learning, and then the matching process actually is, given this key point, what are the matching support comments in the reviews, so that we can do counting and do the quantification, all right? And with this, and then we can do a good matching model, and then we can count how much support we have for each key point, either positive and negative. And here's some preliminary result on Yelp reviews. And you can see here, so this is these are the key points that we have identified from the for summarization, and also for the different data sets of different types of reviews on different topics of different domains. And this is the quantification for matching the counts. And this actually, this result is comparing our matching with the human annotation of the matching. So these are some work. Another topic that we have been working on towards trustworthy data science. That is, we analyze the bias in the opinion summarization process from the large language models, and then we try to work to fix the bias in the model, and to have a diverse and unbiased summarization. Okay, so next I'm going to talk about another topic that we have been working on towards trustworthy data science, which I call information recommendation. So recommender systems are widespread now. When you watch YouTube videos, you got recommendation. When you buy things, especially on eBay, recommendation systems everywhere. But what I'm specifically talking about are such information items. These items contain rich information. So news, right? If you read news on social media, a news will pop up and, feed to you. And then, this news has rich information in there and along different dimensions. And even for movies, there are lots of information about the movies, audiobooks, and all these examples. Actually, this is an interesting example. Even recipes has lots of information because it has, does it have a purpose? Is it a healthy diet? What about, from the dietitian perspective? Is it a good recipe or is it a bad recipe? So lots of information, all right? So what we want to achieve for this information recommendation is responsible recommendation. Conventionally, recommender system are to dig out your personal interests and satisfy your personal interest, make you happy. And that's the value, what I call the personal value of recommender systems. But for information recommendation, if you recommend a movie, recommend some news, there is the social responsibility, there is the moral value, right? So you need to be responsible. And so these are based on some work that we have published in the past several years. And what are the challenges for responsible recommendation? When we recommend news, and we need to be aware there are information sources. As I noted earlier, information sources have bias, all right? And some are left-leaning, some are right-leaning. If your political stance is left-leaning and you like reading, in your reading history, you like reading news from the left only, and if I, don't do it, only follow your personal interests, I will always recommend, left-leaning news. And there's also, more seriously, there's true news and fake news, right? And no matter how we do the fake news detection, rumor detection using machine learning models, still spread on social media. And when we recommend news, there is this important dimension of veracity. Well, you have been find so much interest in reading fake news, and because it is about sport, because it's about entertainment, I'm just going to recommending more fake news to you. But what about the social value of it? All right. Similarly, so for diet, right? For recipes. Well, you like junk food and just, delicious food, deep fries, and I just recommend those to you. So, and similarly books, and similarly video recommendation. So how do we do responsible recommendation? Because in the complex information environment full of true and false information, full of biased information, and we want to do moral value and the socially responsible. All right. So our goal is not only to satisfy your personal interest, not only for personalization. That's not our only purpose. We want to do responsible recommendation of information items. Okay. So of course, the trustworthy data science principles also apply here, especially in this context. What is applies here is transparency, explain your recommendation, and robustness and privacy, especially important because we're digging out personal interest to find out so that we can do good recommendation, okay? And of course, fairness as well because of different groups of users. And recommender systems is especially targeting for end users. And the value, not only personal value, personal interest, and moral value as well. So, across these 4 stages of building a trustworthy recommender system, and what we need from data preparation, when we prepare data, and make sure that there is inclusive, diverse information sources, and trustworthy is applied here. And when we learn the data representation, our focus, learn the representation for user interest, but also disentangle it, also to find out the information veracity or the bias side of information to learn the representation so that we can truly capture 2 dimensions of information, either the user interest, which is one dimension, as well as the other dimension of the representation, which is veracity and bias. Okay? And based on that, we want to achieve fairly accurate recommendation that is personalized, satisfy based on users' interest, but also the recommendation result should be fair and unbiased, and also true information of social value. Okay, and in terms of evaluation, when we do the evaluation should not only be about personal interest, whether it has been met the user's interest, but also about what is the correctness in here. What's the true information proponent that we have been recommending? Okay, so throughout these stages of recommender systems, we want to achieve personalized, responsible recommendation towards trustworthy to win users' trust of our recommendations. So these are the challenges. Okay, again, we need to rely on data science and AI and machine learning to do this. And then we face these research questions. As what I mentioned just now, when we learn the representation, there are multiple dimensions of the data we're looking at. Not only personal interest, but also but also veracity, but also fairness. All right? And then it becomes, what is the definition of relevant? Because relevant is personal relevance. And also the veracity. How can we only recommend true news to users? And when we want to model the higher level user interest, we want to model not only the information item level in the context of news, for example, is not the specific news pieces that we're interested in. We are interested in the news story, the general news story that people are interested in. Okay, so this is a piece of work that we published in WebConf 2020. So in here, we proposed veracity-aware news recommendation. That is saying, when we recommend news, not only look at people's personal reading interests, but also the veracity of the news. All right? So I think I'm running out of time. I will just look at, this just a sketch of the model and along the lines that I described just now, and for recommendation. So this diagram here explains how do we disentangle in the data, in the representation learning phase, disentangle the different dimensions, the veracity from the user interest. All right. So with this, we actually can achieve highly accurate recommendation, satisfying users' personal interest, but also we measure the ratio of true news in the recommendation. Okay. Not only personal interest accuracy, so the classical recommender system accuracy, say like recall, MRR, and NDCG. So it is only measuring the accuracy. In addition to that, we also measure the ratio of true news. All right. And so here are some examples that you can see. So in these examples, so you can see this is someone's reading context. So this is the context news. You can see the green is for true news, and the red is for fake news. And here is our recommender result. So the recommendation result, you can see all greens, okay? So we want to highlight the value of the veracity of the information, not only satisfy one's personal interest. And built on what we did on veracity aware, we actually also introduced the unbiased dimension, that is the fair dimension for recommendation. So when we recommend political news, for example, to people, it's the information sources may have bias. Some sources are left-leaning, some are right-leaning. Even if a user, the personal reading history only have left-leaning news, we would recommend, an unbiased information from the right-leaning sources as well, but also of relevance to the user. So that is what means introduce the bias dimension in addition to the veracity. So that's what we call unbiased and true news recommendation. So in our recommendation framework. So, and here are some preliminary results. And you can see here, again, in the evaluation, and the reason why the metrics are here, because in addition to the accuracy metrics, you can see recall and DCG, but we also have introduced the polarity bias, the measure, okay? and the fairness score when we evaluate the recommendation results. And F1 is just a combination of these two measures, and that's what is reported in this table. And on top of that, we also reported on the proportion of true news. So next, we are working on next? So some discussions. And with the arrival of generative AI, and it is a good thing. It is a tool that everyone can use, can help with research, education, medicine, digital assistant, all good applications. But generative AI can be misused, okay? And it can be used to generate fake news a lot, okay? And so these are two examples here. So this is just saying, actually, back in 2016, at that time, there wasn't ChatGPT, but there are other large language models. And there are bots generating contents. Although it may not be good, but with the arrival of large language model, the level of harm, it can be scaled up very quickly, right? Pushed to a new level. And this is just saying fake reviews can be generated by machines. And this is written actually by a CIO of a company saying that I'm suspecting many of the bad reviews about a company are generated by machines. That's what the content of that review. Okay, so what we are trying to do and what we are working on is, can we work on an AI to police the AI? It sounds very philosophical. I'm not sure whether we are able to achieve it, but we are working on that because it is a very challenging task. So this is what the instruction I gave to ChatGPT. I said, just write me a review for this restaurant, Kaku restaurant. Everyone knows Kaku restaurant? Okay. So, and it writes a beautiful review about Kaku restaurant, a beautiful review. If I put this review on, any website, people would, say, oh, this is a good restaurant. Actually, this restaurant doesn't exist anymore. Okay, so you can see that even for us humans, when we read this, it looks very, grammatically correct, fluent text, no grammar mistakes, very readable. And even humans, can you tell this is something that is hallucinated by ChatGPT. Okay, so this is even for humans, it's very difficult to tell whether a piece of text is written by a machine or by a human. It's very challenging. But given the high stake of these generated contents can bring harm to our society and to humanity, it's some challenge we must address, okay, to make AI safe and make it a tool that is helpful for humanity and society. So some preliminary work that we have done, a challenge in this space, as what I said, if we want to have an AI that police another AI, a powerful AI, and it is keep changing, how can we design our system, our machine learning model, our AI, to be able to cope with the new content, novel out of distribution content that we haven't seen before? That's a challenge. All right. So something else I think it's very interesting is user is very important in this space and for responsible or for trustworthy data science. Now, will our responsible recommendation or our AI algorithms, what effect does it have ultimately on users to win their trust? Okay, so can the responsible recommendation positively change users' behavior of seeking information? Can it? Or, that's an important topic I think we need to focus on as well. So this actually is a picture I took from a Netflix documentary. It is actually The Social Dilemma. If you haven't watched it, I recommend you to watch it. So this is just explaining the algorithm actually can control people. Okay, the algorithm can control people because what we recommend really control users' behavior. And the technology that connects us on social media also controls us. And if we want a good, highly, social good algorithm, will it be able to change people's behavior as well to make people become more aware of the information environment we are facing, and so that to make good judgments. So for that, we actually have set up this real social online environment so that we can collect data and experiment with our algorithms and their interaction with people. So that's what we are working on. Point for your discussion. So quickly summarize the takeaways. And I think I would say trustworthy data science is not a choice, but a necessity. All right? And I have talked about a few pieces of research that we have done towards this, in terms of explainability, in terms of, responsible recommendation, in terms of fairness, but this is only a start. And the rapid development of generative AI and large language models, particularly for textual data, actually presented challenges for us and big opportunity for you guys who are attending the PhD course today. Okay, I think with that, so acknowledge my students and collaborators, and also the support of ARC and Australian Department of Defense. So that's all. Thank you.
I have a question regarding the ethical point of view when you said you mask tweets to see how things go. So let's say masking tweets is efficient. How do you get to decide if you can do that or not?
Okay, so you mean which tweet to mask? Is that what you're talking about?
Yeah, about the rumor spreading thing.
Okay, so you're saying when we do the causal analysis, we actually don't select which tweets to mask. What we do is we analyze, for example, so in here, we actually mask the tokens and one by one, and mask some of the tweets, because it's a collection of mask some of the tweets, and actually we don't choose selectively mask. We just mask one by one and then calculate the effect on the final prediction result. That's what we are doing.
Okay, I understand. Thank you.
You were talking a little bit about GPT-2. I know GPT-4 hasn't been out for as long, but I was wondering if you had any insight on the biases in that language model. And then I also wanted to know how GPT-4 compares to the AI, like Sydney, the Bing one. I didn't know if the connectivity to the internet influences the bias. I guess that was two questions, really sorry. So.
All right. Okay, thank you. So in this study, we have focused on the open language models. That is, the size is actually not that big. We can fine-tune, we can control the parameters. So that's why we did, GPT-2, which is a predecessor of GPT 3.5, GPT-4. And the reason why we're not working yet on GPT-4 is it is by calling the API, we can't control the parameters of those models. And the way to fine-tune GPT-2 is very different from GPT-4. With GPT-2, we can control the parameters, we can do the fine-tuning and see the effect. But with GPT-4, it's through prompting and the different prompting strategies. So it's different ways of fine-tuning on GPT-4. And needless to say, your question is GPT-4, how would GPT-4 compare with GPT-2? GPT-4 is much more powerful, much more powerful than GPT-2. And in the language, the quality of the language that is generated, so it is much more powerful. And you also are, if you want to study the impact of GPT-4 on humans, and then you set up the environment, and the text that is generated by GPT-4 is now of a much higher quality. But if you want to examine the effect of the learning process, then you have to go to an area called prompt engineering. You examine that's the way to examine the way that you can fine-tune the language models for different applications.
A question from agricultural science. Yeah, because I'm from agricultural science. A short question for the agricultural phenomenon, like say phenotyping, is we don't have enough data. Most data is limited. For example, because we need to grow the plant for long term, and sometimes, for example, my sample has lost by the kangaroo eating. So is it any possible can let's say, use the limited data to get more data, or let's say AI generation, or make more data? Is there any possible way for AI?
Okay. Thank you for the question. This is a very interesting question. So this question of data sparsity is actually a widely studied topic in machine learning. So when you don't have training data, sufficient training data to train a model, what can you do? You can do transfer learning, which means you transfer knowledge that has rich data where you can train the model, and then you adapt the knowledge to your domain when you have limited data. You may want to look into papers like few-shot learning or zero-shot learning. Like you can transfer knowledge from another domain where for your domain, your target domain, you only have a few examples, okay? And that's one technique from the model perspective. From the data perspective, actually you have a very good intuition there. The generative AI, you can generate data to augment whatever you have. If you are lack of training data, you can generate data to data augmentation. Put it that way, is a very commonly used technique in the case of data sparsity.
There are many models. How we can choose which one is good for the agriculture? Yeah.
Well, I don't work in the agriculture space, but I don't know whether there are from agriculture the related domains, whether you can have sufficient related data. Like the generative AI is good at generating things. Maybe something called generative adversarial learning. So you can generate for data augmentation. You can actually use some generative models. There's a generator and there's a discriminator. You generate and then criticize. That is generative adversarial learning. So there are many learning paradigms you can investigate. But specifically for agriculture, I don't know. Are there any public domain data set in some specific topic that you can borrow that you can apply to agriculture?
Thanks for a wonderful talk. And I'm focused on legal domain, and I have tried to use ChatGPT to generate some legal text summarization. And I think that's the result is really amazing. And have you compared using ChatGPT for summarization and compared to the research and the summarized model that you have done?
When you say the result is amazing, in what aspect, in what sense do you think it's amazing?
Because when I'm do legal case summarizations, I often just give a whole legal text to the ChatGPT. Then, because it was summarized just based on the exact text, so it won't exceed some like untrustworthy information or something like that, or is reasonable as I see. So compared to other summarization tools, I didn't get that wonderful result. So I think that's good enough for legal case summarization. Yeah. So I just want to ask, have you compared the ChatGPT generate summarization to what you have done on the summarization?
I have used GPT 3.5 summarization, but mainly in the social media data summarization for opinion summarization. I haven't worked in the legal domain, but what I can comment on is a critical issue of the summarization using these generative AI tool or models is hallucination. How do you make sure, especially in the high stake domains like legal, how do you make sure the generated summary, the text, is grounded in the truth, the facts, in the source data? So that's a critical thing, and researchers are still working on for summarization for areas that are high stake. And solutions people have been investigating, including using existing knowledge base, for example, that we know the exact fact, and how can we generate critiques, to make the generated contents of GPT in the inference process to be grounded in the things, in the facts that we already know. I know that's a very important, critical thing when you apply it for high-stake applications like legal.
Thank you for your wonderful presentation, and I like the way you use the causal analysis as an attempt to understand the black box model. And I was wondering, like, since you're using the language data, and I'm working on the time series data, and I think they are similar because of the sequential
What data?
time series data.
Time series.
I think because of the sequential nature of both this data, I guess I could also apply similar method to my research. So I just want to know, like, what are your thoughts on using this kind of analysis on time series, especially irregular time series data set?
These language models, they are all sequence models. They are just modeling the sequence. So the transformer architecture actually is very powerful for modeling the time series data. And definitely we have the right intuition to apply these to the time series data because it is a sequence of, rather than a sequence of tokens, but a sequence of values, right? And one thing I do want to note that these sequence models, they actually haven't really made use of the timestamps, if you think about it. Only use it as first, second, next, like it's just a sequence. Hasn't made use of the timestamps. I just want to note that, and that's something, like for the time series data, my students has been working on also using these models to analyze the time series data for various applications.